All right, here's the follow-up. The next section of logs. We kind of did the basics yesterday, and now we're going to get into really just some more of the basics. It feels like something new at times, but it's actually not. We're going to get into solving with logarithms, and a question you might be asking is, what in the world do you need a logarithm for? It's a great question, and actually, at a time when a disease is spreading throughout the world, this is a great time to talk about exponential growth and logarithms. So we'll get the basics today, and then we'll figure out how it can actually apply next coming days. So how do you solve a logarithm? Here's what I'm asking you. If I want 10 to the x power, well, how do you get an x power to come down and not be an exponent anymore? Many people say, hey, how about you divide by 10? Divide by 10, you get, but it's not 10 times x, it's 10 power x. And if you remember what are opposites, your powers and roots are opposites, not multiplication and division in this case. So how do you get it down? Well, what you can do is you can rewrite it in its other form, in its log form. So its log form looks like this. You write the word log, and then you write the word base, and it goes like this. The base, and then here's the number you're logging, and it's going to be equal to the exponent. Well, how is that helpful? I'm asking you 10 to what power is going to be equal to 8. The reason that's helpful is because right on your calculator you have a couple of these. So you have two logs that are right on your calculator. There's more, but the handy ones are right here. You have a log button, and that's what it does. That does a log base 10, those common logs that we talked about. So if I just hit log 8, notice the number 10 doesn't show up there. Anytime you don't write the number, the base, then you can just assume that it's a 10. So log 8 is going to be 0.9. So we're not getting a nice clean number. That's okay. All right, I'll try one more. Notice the base isn't written here, but now I'm saying, all right, I'm logging a number, and I'm not telling you what it is, but I'll tell you the answer is 5.5. Well, it's easy to get overwhelmed until you put it in its other form. In its other form, you can go like this. All right, it starts out as a 10. It turns into an x, and the exponent is out here. So if we get good at putting things in exponential form, you can just, oh, that's easy. Go 10 power 5.5, and you've got it. It's a big number, 316, 227. 0.8. All right, you pause it and see if you can do the last two. All right, once again, if you want to know 10 to what power, that's what the logarithm is asking you. So I would write it as log with a base of 10 of the number 4 is going to be equal to x. So on my calculator, I can just push log 4, and there you go, 0.6 or 0.602 if you want to be exact. The last one, I didn't show you one like this before, but what's the base? Well, don't get overwhelmed. Let's put it in its other form. It says the base is b, turns into a 5, and the exponent is a 10. So base, what it turns into, and there's the exponent. Oh, not so bad. How do you get rid of a power 10? We always use fractions, a reciprocal power. So go on here and go 5 power, 1 divided by 10, and you have 1.17. All right, last thing we'll talk about today, and then just have some review problems, is how do you graph it? How about log base 2? How in the world do you graph that? Well, plugging numbers in for x and getting numbers out can be tricky, unless you have this here paper. This paper actually makes things quite nice. So let's try a couple, maybe just up to the top here, like log base 2. Let's just plug in some numbers that we think are going to be easy, like 2. What would be log base 2 of 2? Well, here's what I'm asking you. If it starts with a 2 and ends with a 2, what's the exponent that changes a 2 into a 2? Oh, so it's going to be power 1. Okay, so when I do that, if I plug a 2, I get out a 1. So plug a 2, get out a 1. So 2 comma 1 is going to be 1 point that's on the graph. Well, actually, these logarithms, the ones that you want to look up, are actually just row 2 on here. If you plug a 2, you get a 1. If you plug a 4, you get a 2. If you plug an 8, you get a 3. So if I had log, let me find some room to write, log base 2, let's plug a 4. What is log base 2 of 4? Well, I don't know if I said this on a previous video, but anytime you want to do logs a really easy way, just put your finger on the 2, put your finger on the 4, find the exponent. Hey, there it is. What's log base 2 of 8? Put your finger on the 2, put your finger on the 8, there's the exponent. So what would be log base 2 of 64? Put your finger on the 2, put your finger on the 64, there's the exponent. Kind of a nice way. So if you want to do these logs quickly, you can say log base 2 of 2 is 1, of 4 is 2, of 8 is 3, of 16 is 4. So you can just graph 2, 1, 4, 2, 8, 3, and then actually that's too big to be off the graph. So we'll have 2, 1, we'll have 4, 2, and we'll have 8, 3 on our graph, and it looks like this. Okay. Now, what is it going to do as it comes down here? Is it going to cross the graph? Is it going to get close? Well, to answer this question, we have to think about what is the logarithm. This happens every year where we talk about the log, we have lots of lessons about it, we do lots of homework, do some really difficult problems actually, and then I get to the very end and I say, what's a log? And a lot of people say, I don't know. What it is the inverse of the exponential function that goes with it. Okay, we talked about that yesterday, but log y equals log base 2 and y equals 2 to the x. These are not the same equation, these are inverses of each other. They're opposites of each other. So I'm going to do a light sketch of y equals 2 to the x. We've graphed it before. It looks like this. It's got an asymptote here at the x-axis, and then it swoops up. Well, let's think back. So that's y equals 2 to the x. Think about what we know about inverse functions. Inverse function, things that are inverses. What we know is that you take the x and the y and you flip them. So if this point has the point -2 comma small decimal, you're going to switch the x and the y. I'll have a small decimal comma -2. If this is -3 with a small decimal, it'd be a small decimal -3. And so what happens is that this asymptote here gets reflected and you have the exact same idea, but just on the y-axis. So, a couple things. So this graph was just here to help. This graph here, this dark one, is the one that we actually care about. All right, a couple things. What's the domain? If I want to figure out the domain, that's just the x values. Notice x values, it starts at 0 and goes to the right. So x has to be strictly bigger than 0. What's the range? Well, if you look, it starts to go here, it goes up, and it's going to go up forever and ever and ever. It's also going to go down forever and ever and ever. So we're going to say -infinity to infinity is going to be the range. If we want to point out an asymptote, right here, your y-axis is the asymptote, the line that gets approached but not touched. There you go. All right, this other one did not copy very well for me at all, but I'm just wondering what log is being graphed here. Well, if you notice right here, log base 2 has 2 comma 1. So if I want to look at this right here, if I want to figure out what log is being graphed, I see right here there's 4 comma 1. So whatever number has 1 for a y value is going to be your base. So log base 4 is going to have 4 comma 1. So I know that this is y equals log base 4 of x. All right, your homework is not going to be new stuff. It's just going to be practice for what we've already done.